How's it going, guys? I'm Connor here, and we're going to discuss 2008 Form B number 6 for your response, mostly on implicit differentiation. So first thing is you got your given equation, and you're supposed to show that dy dx equals negative x minus 1 over 2y cubed plus 2. So the first step you're going to do is separate your y variable and your x variable. So that way we'll have y to the fourth plus 4y equals 5 minus x squared minus 2x. Next step is you can actually take your derivative. So we're going to have, that was bad, 4y cubed plus 4, but that's all going to be by dy dx equals 0 minus 2x minus 2. So then we can divide over by our new function, our derivative function. So we have dy dx equals negative 2x minus 2 over 4y cubed plus 4. And so we can get it over to our function that we need. We're going to take out 2 and 4. So we're going to have negative 2x minus 1 or plus 1 over 4y cubed plus 1. That way 2 is going to be pulled out of the equation, so that way we can have x plus 1 negative in front of it over 2y cubed plus 1. There you go. There's your first answer for part A. So your second problem that you're going to have to do is find the equation for the line that's tangent to the curve at point negative 2 comma 1. So what we're going to do is we're going to plug in our x and y components into our dy dx function. So for part B, plug in point negative 2 comma 1. So we're going to have negative 2 plus 1 over 2, 1 cubed plus 1. So that way we're going to have 4 on the bottom and 1 on top. So that shows us what our dy dx equals. So our rate of change at point negative 2 comma 1 is going to be 1/4. So now we know what our slope is. So we're going to plug that into our slope-intercept form. And here's our point, so that we're already done. So we have y minus 1 equals your slope, so 1/4 times x minus, which is actually going to be a plus, 2. Your equation for your slope, your line that is tangent to the curve at point negative 2 comma 1. So our next step is part C. Part C, got to find coordinates for the 2 points on the curve with a vertical tangent. So at this point, we have to set the bottom of our dy dx equation to 0, because then you have that vertical tangent where it never meets. Guess, yeah, a little lost, not gonna lie. That was a terrible C, who cares, this is math class. So we're gonna take our dy dx equation, so for the bottom part, we're gonna plug y cubed, so the bottom has to equal 0, so to cancel out that positive 1, y cubed equals negative 1, which just means y equals negative 1. So now that we have this equation, we're going to plug it into our original equation. So x squared plus 4 times negative 1. Oh, forgot the 2x. 2x plus x squared plus 4 times negative 1 plus y, man, out of this. Negative 1, to the fourth equals 5. So now that we have that, what we have to do is solve, which will just give us x squared plus 2x minus 8 equals 0. Now we just have to factor, and then those are our answers basically. So we're going to have x plus 4 and x minus 2. Now that we have those points, we just solve so that it's basically negative 1 is the y component. So we have 2 comma negative 1 and negative 4 comma negative 1. These are the 2 coordinate points where with the vertical tangent. So there we have it. That's part C. So now on to part D, and we're supposed to show if there's able to be a horizontal tangent for this curve where it intersects with the x-axis. So that means if it's intersecting with the x-axis, that means y equals 0. So to make it a horizontal tangent, the numerator has to equal 0 for the dy dx term. So we take our dy dx, negative x plus 1 over 2 parentheses y cubed plus 1. Numerator is going to have to equal negative 1, equals negative 1, yeah. And we already know that y is going to equal 0 because it intersects with the x-axis. So now that we know that x equals negative 1 and y equals 0, we plug this into our original equation. So we have negative 1 squared plus 2 times negative 1 plus 4 times 0 plus 0 to the 4th equals 5. So then we solve. So it's going to be 1 plus negative 2 plus 0 equals 5. Sad fact is, negative 1 is not equal to 5. That's all we got. So that means, no, it is not possible for a tangent line horizontal that intersects the x-axis. That's our problem.